Hello students, welcome back to chemistry class. In the previous class, we have discussed the hydrocarbon and its classification. The hydrocarbons can be classified into two. They are saturated hydrocarbons and unsaturated hydrocarbons. The saturated hydrocarbons are also known as alkanes because the carbon-carbon bond which is present in the chain is single bond. And the unsaturated hydrocarbons, they are mainly two types. The one, if the carbon-carbon bond is double bond, which is known as alkenes. If the carbon-carbon bond which is present is triply bonded, which are known as alkynes. So, alkenes and alkynes together called unsaturated hydrocarbons. Till there we have discussed. And today we are moving on to the general formula of alkane series, alkene series and alkyne series. Okay, how will you find out the general formula of these three series? Okay, let me write one example of an alkane. So if I write ethane, so how will you write ethane? Ethane means two carbon with the remaining four valencies are satisfied by hydrogen, right? This is ethane, second member of alkene, ethane, and the chemical formula C2, total number of hydrogen H6. Okay, and if you write one example of alkene, if I write alkene like ethane, two carbon with the double bond, and the rest of the valencies are satisfied by hydrogen, and this is ethane, first member of alkene, and the chemical formula C2H4. Just count the number of carbon and hydrogen, then you will write the chemical formula. And coming to the alkyne, if you take the first member, it is ethyne, and already triply bonded and one hydrogen is remained to satisfy the valency. It is ethyne, the first member of alkyne series, and the chemical formula C2H2. Okay students, look at here. This is ethane. When it comes to ethene, what happens? Double bond has come. That time two hydrogen is reduced. Okay. When it comes to the ethyne, again one more bond has come. Again two more hydrogen is reduced. Okay. So when you write the general formula, of a series, so generally you can write in the alkane series, the general formula is CnH2n plus 2. CnH2n plus 2. N is the number of carbon and N is the number of hydrogen which is present. Right? When coming to the alkene series, how will you write the general formula? The general formula is CnH2n. Why only H2n? Because 2 hydrogen is reduced. Look at here. So this plus 2 is not required. This is CnH2n. When coming to the alkyne series, what is the general formula? Again one more bond has come. That time 2 more hydrogen is reduced. Okay. From this 2 more hydrogen is reduced when it comes to alkyne. So general formula CnH2n minus 2. This is the general formula of alkyne series. Okay, you can continue this series by using this formula. The next member is C3H8 and the fourth member C4H10. Just add 2 hydrogen and 1 carbon. And who is the next member of this alkene series? Use this formula. Yes. After C2H4, the next member is C3H6. The next member is C4H8. The series continues like this. According to the general formula. Who is the next member after ethane? It is propane. C3H4. Who is the next member? C4H6. The series can be continued according to this general formula. Okay. So when bonds are comes, if the bonds are comes in particular chain, you can see that the total number of hydrogen decreased, but the series continuously going like that. Okay. And again, if it triply bonded, again the number of hydrogen reduced and the series can be continuous like this. Okay. Here I have written the second member of alkane series, that is ethane. And the ethane is the first member of alkene series, and ethyne also the first member of alkyne series. Okay. Okay, students, till now we have discussed the open chain hydrocarbons, right? And now we are moving on to the ring hydrocarbons or ring compounds or closed chain compounds. Okay, or it can be called cyclo or cyclic compounds. Cyclic compounds. The next category of hydrocarbon. Okay, ring compounds or cyclic compounds or closed chain compounds. Any name you can call. Okay, students. In ring compounds, mainly there will be a ring, right? But in the case of hydrocarbons, what we discussed earlier, that was a long chain compounds. If I write an example of alkane, like if I write hexane, how will you write hexane? If you write hexane, you can see total number of carbon, it is 6 carbon, right? 1, 2, 3, 4, 5, 6. And the valencies should be satisfied by hydrogen. So this is hexane. This is hexane chain. 6 number of carbon atom with the hydrogen. It is known as hexane. Hexane. This is alkene. This is a best example of alkene called hexane. No doubt, 6 carbon. Both bonds are simply bonded. This is hexane. So how I make it to a ring compounds? I just want to close the ring. How the hexane can be converted into cyclic hexane or cyclohexane. For that, what I have to do is take the chain and just close the ring with the 6 carbon. Take the chain and close the ring with the 6 carbon. First you close the ring. Okay. So after that you just satisfy the valency. Already 1, 2. 2 valencies are satisfied. Next 3, 4. 1 carbon atom, 4 valency. And the second carbon atom, 2 valencies are already satisfied. It is again 2 more. Total 4. This carbon atom, 2 is already bonded. And again 2 more is required. And this carbon atom, 2 valencies are satisfied. 2 more hydrogen is there. Here also 2 valencies are satisfied. 2 more hydrogen is required. Here also 2 valencies are satisfied. 2 more hydrogen. Okay, children, what is the difference between these two? This is a straight chain hydrocarbon and this is a ring hydrocarbon. Okay, count the number of carbon and hydrogen. C6, H, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11, 11 plus 3, 13, 14. H14. And here also you please count the number of carbon. C6, H, H12. H12. This is normal hexane or straight chain compound. And this is known as cyclohexane. When you close the ring, 2 hydrogen is reduced. So C6H12 is the chemical formula of cyclohexane. This is also saturated because no double bond is present. The best example of cyclic compound, it is cyclohexane. Okay, I will show you another example. If I draw a 3 with the hydrogen. What it is called? It is propane. It is propane, right? It is propane. Okay, this is normal propane. I just want to draw the cyclopropane. I just want to change this normal propane into cyclopropane. How I draw the cyclopropane? For that, the ring should be closed. The 3 rings should be closed. After that, the valencies should be satisfied. Okay, after that, the valencies should be satisfied. This is propane and this is cyclopropane. Cyclopropane. And if I draw butane, how will I draw? 4 carbon atom with the hydrogen. 4 carbon atom with the hydrogen. This is butane. This is butane. How I converted to cyclobutane? Just close the carbon. Just close the 4 carbon with the ring. I close the ring and I just want to satisfy the remaining valencies with the hydrogen. This is cyclobutane. You can write cyclopentane, cyclohexane. We have already written cycloheptane, cyclooctane. Many compounds. Whatever examples you want, you can draw it. Okay? Okay, students. Till now we have discussed saturated ring compounds. Saturated ring compounds we have discussed. And now we are moving on to the unsaturated ring compound. Okay. In order to write the unsaturated ring compounds, first you draw a cyclohexane. Cyclohexane ring first you have to draw. You have already drawn this. The same ring you just draw again. I just want to show you the transformation. How this cyclohexane will convert it to benzene. This is cyclohexane. Okay. How can I convert it to unsaturated compound? For that, draw the 6 carbon ring again. Draw the 6 carbon ring again. Okay. And what you have to do is put alternate double bond. If I put double bond here, next double bond will be here. Next double bond will be here. Okay. That time how many hydrogen is required for this carbon? Only 1. Here also 3 valencies are already satisfied. 1 hydrogen is required to satisfy the valency of hydrogen. Okay. This is C6H12 cyclohexane and this is C6H6. This is saturated cyclic compound. This is unsaturated because double bond came in between and the name of this compound is benzene. The name of this compound is benzene. This is the best example which is there in your syllabus. Benzene have many peculiarities, like benzene will show particular characteristics and it is highly poisonous also. Most of the organic compounds are highly poisonous. So this is the one of the important unsaturated hydrocarbon. So you can draw other examples of unsaturated hydrocarbons, like how can you draw cyclopropene? If you want to draw the cyclopropene, first you draw the cyclopropane. First you draw the cyclopropane. How will you convert it to cyclopropene? Yes, just put a double bond and reduce the number of hydrogen atom. Reduce the number of hydrogen atom. That time you will get cyclopropene. Right? Yes, you can draw cyclopentene, cyclobutane, cyclohexene. Okay. How will you draw cyclopropyne or cyclobutane? How will you draw? 4 carbon atoms should be closed. closed. Somewhere you have to draw the triple bond. Okay, you have to draw the triple bond. And here need not put any hydrogen because already the valencies are satisfied. Here the hydrogen is required. This is cyclopropyne. Cyclopropyne. And this is cyclopropane. Propane because double bond. This is propyne because triple bond. Okay? And these three are the examples of unsaturated hydrocarbon. And the benzene is the best example which is there in your syllabus. Okay? The properties of benzene and all you will study in the higher classes. Okay?